Hey guys, how's it going? Just wanted to film here the last two lessons that will carry us really through the end of the year. Um, Couple points of emphasis. This day of notes kind of goes along with, I think it's day 64 homework and free response 33. And then the other section of notes, which I'm going to film here in a minute, goes with the other day of homework. Both of those days of homework will be due uh, by the end of next week. If there's anything that you have not finished or completed, you have all the way until May 22nd to get those things done and submit those to me. And then on the 23rd, I'll go in and calculate fourth quarter grades, and we'll go from there. So today we're talking about circular trigonometry and the unit circle just a little bit. We'll talk more about the unit circle when we get into this next lesson. But we really have some terminology that we need to get through today. The first thing we're going to do is just kind of draw three different circular angles in standard position, measuring 215 degrees, 575 degrees, and negative 145 degrees. The pictures of them are already drawn there, but just kind of a couple of things to really point out that are important. When we are drawing these angles, the initial side is always going to be the positive x-axis. So when I go to draw my angle, this right here is always where we are starting at. Okay, the positive x-axis. Now, if I were to draw 215 degrees in standard position, I would have to start right here, and I'm going counterclockwise. And I'm going to go counterclockwise 215 degrees. So there I'm at 90, 180, and I'd have to go 35 degrees more. And that would be my 215 degree angle. For 575, I start off at my initial side, and I'm just going all the way around. There's 360 degrees, and I have to keep going until I get to 575. Negative 145, the only thing that's different about negative is you just go in the opposite direction. So I go down 90 degrees, keep going, and there I have went 135 degrees. So notice there, all three of those angles have the same initial side and the same terminal side, which means that that's where they stop. The other thing that they have in common there is they have the same reference angle. So the reference angle in all of those is 35 degrees. It's important to know the reference angle is always going to be the angle that gets you from your terminal side back to the x-axis. So if I had an angle, let's say it was, here's my initial side, arrow of rotation is there. There's my terminal side. Here, right in there would be my reference angle. It's the acute angle that gets you back to your x-axis. All right, so the main thing that's different between those three angles, even though they're all kind of pretty much the same, is that they have a different arrow of rotation. They all start off with the same initial side. They all have the same terminal side, but the arrow of rotation is really the same with all of those. So one of the things that you guys are going to have to do is just being able to just draw your angles in the correct spot. Another thing that we need to go over real quick is the quadrants. So the top right, I have quadrant 1, quadrant 2, there's 3, and there's 4. So in quadrant 1, the x value and the y value would both be positive. In quadrant 2, x is negative, y is positive. Quadrant 3, they're both negative. And in quadrant 4, x is positive and y would be negative. We're going to use that when we get into the next section of notes, and we'll start talking about the unit circle a little bit more. Okay. So those three angles, just another terminology, another word for us, are called coterminal angles, just because they end and have the same terminal side. So here it is right here. Sometimes we're going to be given an angle, and then it says to find one positive and one negative coterminal angle. So if I have an angle and I know where it ends at, I could find other coterminal angles to that angle by adding or subtracting multiples of 360. Now, if I had an angle that was 75 degrees, let's say, if I wanted to find another positive angle or positive coterminal angle to 75 degrees, I would just add 360. If I wanted to find a negative, which means we would go in the opposite direction to get to that same terminal side, I would just subtract 360 until I get to a negative number. All right, so now we get down in, we're really going to start talking about the unit circle just a little bit. And this is the whole idea of the unit circle. Is if you had the center of your circle being at 0, 0, and the radius being 1, and you draw a circle around the origin with a radius of 1, that right there represents the unit circle. So we saw in this last section of notes last week, some of us were completing work where our calculator was in radians and not degrees. Let me explain what that means. What radians represents. So I know that if I go all the way around a circle, that is 360 degrees. Now, in terms of radians, we're really talking about the length of the arc or the circumference around the circle. So if my radius was 1, which it always is in the unit circle, how do I find the circumference of the unit circle? I'll just use 2 pi r, where the radius is 1, so it's 2 pi. So that is really in radians. Radians really thinks of it as, all right, if 2 pi is all the way around your unit circle in terms of distance, radian measures just kind of breaks it up into different chunks of that. If I only went halfway around the unit circle, that would be pi radians because it's half of 2 pi. If I only went a quarter of the way around the unit circle, my radian measure would be pi over 2. Pi over 2, because I know that I go halfway around half of the circle, which would be pi over 2. So this one right here would be pi over 2 from our initial side going up the pi over 2. All right, so the one thing that we need to talk about, and it really carries the rest of this section of notes, is how to convert between degrees to radians and radians to degrees. So we got 2 basic formulas that we are going to use. To convert from degree measure into radian measure, you take whatever your degree is and you multiply it by pi over 180, and that tells you your radian measure. We got 2 examples down here below. 90 degrees. So if 90 degrees is a quarter of the way around a circle, if I wanted to know what my radian measure would be, I would take 90 degrees and multiply it by pi over 180, and then I would reduce my fraction. 90 over 180 is pi over 2. Here's another one, negative 235 degrees. I would multiply that by pi over 180, simplify my fraction, and then there is my radian measure, negative 47 pi over 36. Now, the opposite of that, to convert from a radian measure into degree, you just take your radian measure, whatever it is, and multiply it by 180 over pi. Basically, the exact opposite is what we did before. So if I have a radian measure, and radian measure is really always going to have that pi symbol in it for the most part. We really like to leave that pi symbol in just to give us kind of more of an exact answer. So 2 pi over 3 radians, to convert that to degrees, I'll multiply by 180 over pi, and I get 120 degrees. Negative 13 over pi, or negative 13 pi over 6. Changing that to degrees, I'll multiply it by 180 over pi, and we get negative 390 degrees. All right, so same thing on the last one. We kind of have some options here. So it says instead of degrees finding a coterminal angle, we want to find a 1 positive and 1 negative coterminal angle, but they're giving it to you in radians. So the easiest thing to do to find coterminal angles with radians is to just go ahead and convert it to degrees, and then you could add or subtract multiples of 360. If you wanted to leave it in radians and find a coterminal angle, instead of adding or subtracting multiples of 360, you would have to add or subtract multiples of 2 pi. And we can find coterminal angles that way. So and I would just have my radian measure as my final answer, which is what they did on this next example. Right here, I added 2 pi and subtracted 2 pi over here. All right, so the last thing here, given the angle, determine the quadrant in which the angle terminates, and then find the measure of theta prime, which is the reference angle. So the first one, 275 degrees. I start at the initial side, and I use my arrow of rotation to kind of go around until I would get to 275 degrees. So I'll know I would go 90, 180, 270, and I would need to go 5 degrees more to get to 275. So my reference angle, once again, is always going to be less than 90 because it's going to go from the terminal side straight back to the x-axis. So my reference angle in this one's 85 degrees, and that terminal side is in quadrant 4. Negative 579, I start here on the initial side. Since it's negative, I'm going to go in the opposite direction. So I go down 90, 180, 270, 360, 450, 540. So I'd have to go 39 degrees more to get to negative 579. So my reference angle from my terminal side straight back to the x-axis, 39 degrees. And that is in quadrant 2. The last two, it's always a little bit tougher to think about because it is in radian measures, but you can see here the first thing they did with 13 pi over 6 is convert it to degrees. 390 degrees. So 390 degrees all the way around is 360, so I need to go 30 degrees more. Excuse me. I need to go 30 degrees more. Then you'd have to actually write my reference angle. I want to know what it is in radians, so I would just take 30 degrees and convert it back to radians, multiply by pi over 180, and we get pi over 6. Pi over 6 is actually a pretty big radian measure in terms of we're going to be using that a lot in the next section. Pi over 6, pi over 4, pi over 3, pi over 2. Those are all pretty big ones. And obviously that is in quadrant 1. And the last one, negative 3 pi over 5. If we want to convert it to degrees first, you can just multiply by 180 over pi, get negative 108. So I start at my initial side, the positive x-axis, and I'm going in the opposite direction. I go down 90 degrees, and I would have to go a little bit further. So my reference angle, 72 degrees, and then they just converted that back into radians. All right, so that's it for this one. Like I said, I'll post the other section of notes here in a minute.